Perfect, thank you. Okay, I think we're just about ready to get started. Okay, so in today's webinar, I will be demonstrating and explaining CYPEFIRE sprinklers and CYPEFIRE FDS. If at any moment you have any doubts or questions, please just let me know in the chat. Okay, so to start, we go to the BIM Service Center, and I'm at the home page, and I'm going to create a new project. As we don't have a lot of time and I have to get through 2 programs, I'm going to go through this part a little bit quickly. So if you have any questions, just let me know. Okay, so now that we have our project, I'm going to open up IFC Builder. Sorry. Can everyone hear me? I've got someone saying they can't hear me. Okay, I'm just going to continue. Abdul, if you want to check your settings. Okay. And just in case you can't hear Abdul, we are recording the video, so I can send you the recording. Okay, let's continue. So I'm going to open up IFC Builder. And for the sake of this demonstration, I'm going to open up a pre-built BIM model. I'm going to open offices. Okay, so if you're not familiar with the IFC Builder, it's a free CYPE application designed for the creation and maintenance of IFC building models. It's simple to use and integrated in the Open BIM workflow. Okay, so using the program, we've created a simple office building that you can see here. If I use the 3D view, you can see the entire building. And with this finished building model, we can export it to our project that we just created. Demonstration. Accept. Okay, and it'll just take a few seconds, but it should upload. Okay, it says it's uploaded. I'm going to check. Go back to my project, and there's my model. So now we can open this in CYPEFIRE sprinklers. We're going to create a new file. Select the project. Here's the BIM model that's attached to our project. We'll import that. Here we can import all the floors and all of the different space types in the building. No errors. Okay, so this is the main interface of CYPEFIRE sprinklers. It's divided into 4 areas. We have the workspace window, which we can navigate using the mouse wheel to zoom in and out. We can hold down the mouse wheel to pan around the screen, and we can use the left click to select elements in the window. To the left here, we have the project, or the project tree, where we can navigate through the different floors with the left click. We can activate or deactivate the floor plans from IFC Builder, and we can edit each of the floors. We can edit the reference, but most importantly, we can edit the sprinkler installation height, which I will get back to once we're installing elements. And below that, we have the 3D model viewer, which we can use to view the 3D model, and we can also use to view any elements that we have put into the model, which is a nice quick verification tool. We have various tools for filtering what you want to see, such as the floors there. Okay, and then at the top we have the primary element toolbar, which is used for configuring the project settings, inputting elements into the project, and useful for its analysis tools. Okay, so the first step is to go into the general options and configure the options for our project. The first option is to configure the general data. So here we have a few options to change the design options, such as the calculation equation, which can be changed between Hayes and Williams or Darcy-Weisbach. We can alter the pressure drops if we want to activate those or not. We have a few settings for sprinklers, and we also can activate or deactivate the seismic analysis tools. For this demonstration, I'm going to leave that deactivated. We have an option here for including any additional project data, such as a name or location, but we can leave that. And below general data, we have the libraries. We start with the space types tool. As you can see, they all have the cross mark next to them, and that's because before you start a project, you need to come into this tool and individually check each space. For example, if we go into the dining space, we need to make sure whether or not sprinklers can be installed and adjust the hazard in construction type. For example, I could set the dining space as ordinary hazard, non-combustible, unobstructed. If you need any clarification for the hazard or construction type, a lot of the tools have a question mark next to them, which gives a clarification for the variable that they're attached to. Close that and accept, and now it's been checked. So I'm just going to go through. I'm going to go through and check all of these. The code that is running in the program right now, the norm or the standards that it's using is the NFPA 13 code. So all of these standards are according to that code. So I'll go through. Okay, so they've all been checked. And next we load in all the element libraries. So we'll start with the sprinklers. We click to add new element to the list. You can't, sorry, can anybody hear me? I'm just getting a message that you're having difficulty hearing. It's saying here that the microphone's picking up sound. Yep, okay. All right, so yes, we can add a new type of sprinkler. You can designate a reference, a type, an installation orientation, K factor, thread type, and type of response. You can also use one of the pre-configured sprinkler types using this blue arrow, and that's what we're going to do. We're going to use the pendant sprinkler K80 standard coverage. So it will load the settings in for that sprinkler, accept, and now it's in the library. Next, we have the pipes catalog. Again, you can manually input a reference, Hayes and Williams coefficient, a Darcy-Weisbach friction factor, the pipe material, and various pipe sizes, as well as outside diameter, wall thickness, and weight. Or you can go to the blue arrow and load some of our pre-configured materials, which is what I'm going to do. And as you can see, it loads in a selection of different sizes for each of those pipes. Next, you can load in a fire hose reel. At the moment, the only property that you have to worry about is the flow rate at 190 liters per minute, so we can accept that. The hangers catalog, again, manual introduction is possible. You have various configurations such as pipe size, different dimensions. For clarification, you can use the question mark in the top corner so you can see what each of those dimensions is referring to. But you can also, again, use the blue arrow and load the pre-configured loop hanger with a selection of different pipe sizes. And the sway braces, and fasteners catalog will refer to the seismic analysis tools, so I can leave those empty as we're not going to use those. Okay, so now that we have configured the installation, we can begin placing elements. So the first thing you want to place is the supply connection, and you have the option of either using a supply connection or using the combination of a tank and a pump. I'll start by placing a tank. And so here I'll firstly like to point out that you have these lock symbols next to various variables. And so the purpose of these lock symbols is to show that if you leave them blank, the software will be able to fill in that information without any of your input using the other data that's available in the installation. However, if you would like to input your own data, you can do so, but you have to make sure that you lock your value in. I'll be able to show you this in more detail later, but okay, so with the tank, you can designate a hazard type, capacity, and a flow. You can also see in a lot of the tools, we have a consult checks option. And if you click that, it will give you some more information about where this data came from and at what part of the NFP A13 code it's from. So we can place the tank. I'm just going to activate the grid. You can see on the side of the workspace window here, we have a number of tools that help you use the workspace. So I've activated the grid and the snap to grid option. So I place the tank with the left click, and here we have the pump prompt. So we have the properties for the supply pipe, and we also have the flow pressure curve, which you can alter however you like. You can alter it based on the midpoint. You can alter it based by individual points, and manually input your own points in, or you can load one of the pre-configured pressure curves, such as this one, and accept, and then place with the left click. And the other supply connection that you can access is the generic supply connection. So from here, you can alter the hydraulic design parameters. And again, you can alter the vertical supply pipe parameters as well. Click accept and place with the left click. Okay, so the next section in the primary element toolbar is for the placement of sprinklers, arrangements of sprinklers, and the protection area for sprinklers. So this button is for the manual placement of single sprinklers. And so the prompt here allows you to determine sprinkler properties, including hazard type or construction type. For instance, if I change this to an ordinary hazard group, and I place this within a room that's designated for light hazard, this would automatically change to light hazard as I've left it unlocked. However, if I locked it, then it would stay with ordinary hazard. So I've just got a question asking me how I can introduce alternative codes into the model. I'll just get to that question later. I won't forget. Okay, so below sprinkler properties, we have 3D arrangement. And so this is where the settings for the floor plans was very important. So the default arrangement is 2.7 meters above the floor. And if you want to put in sprinklers or pipes at a different height to that, this is when you really need to use the lock-in value setting here to overwrite the default value. And below that, we also have a sprig, which allows you to add in sprinklers at a certain distance below the pipe that you're attaching it to. So you just need to designate the drop distance and the properties for the connection pipe. Okay, so if we accept, we can simply place sprinklers with the left click, and when we're finished, right click, cancel, and there we are. So as we've placed these sprinklers manually, they don't have a protection area, and so we have two tools for the placement of protection areas. The first one is a manual tool for dragging and drawing. Select each corner with the left click, and you right click to finish. I'll just change the background color so it's a bit more obvious. Black. There we go. And the other tool is an automatic protection area generator. So you have two options between circular or rectangular. So what I'm doing here is I'm just left clicking on the sprinkler that I'm choosing and then right clicking to activate and right clicking again to cancel out of the command. And so these other tools that we have here are for the placement of multiple sprinklers in a series. So we have the same properties as before, but below that we also have settings for the branch and settings for the protection area. So we can alter the spacing between the sprinklers, for example. I'll just demonstrate here. So I left click and drag, and I have a branch of sprinklers in series. And you can see that they have automatically generated protection areas, which you can edit to be however you like. The next is the cross main with branches. Again, you have the same settings as before. The only difference is this variable at the bottom for the number of sprinklers on each branch to the left and to the right. So as you can see, as I drag, there is a branch to the left and a branch to the right. And the last one is a grid system, with the new setting being the number of sprinklers per branch. If I set that to 2 and accept, I have 2 sprinklers on each branch off the cross main, just like so. Okay, I'll leave the design scenario just for a minute, and I'll explain how to place pipes. So for the placement of horizontal pipes, you get the following prompt, where you can adjust which pipes catalog you would like to use, the size of the pipe, the type, and then below that you have 3D arrangement again, just like with sprinklers. If you want to place it at a different height, you need to use the lock here, which I will demonstrate. So if I place a pipe like this, we can see here on the ground floor the default sprinkler installation height, 2.7 meters, so that's the height that it's installed at. However, if I want to place a pipe at 1 meter above the floor, I'm going to need to lock that value in to overwrite the default height. And there we go. Just make sure I'll avoid mouse. Yep. Okay. And just to demonstrate that it's at a different height, I can refresh my 3D viewer. And here you can see the 2 different heights of the pipes. You can also see the various sprinkler arrangements that we placed. Okay, and for the vertical pipes, there's 2 options. The first is a riser, and the riser is useful for connecting pipes at different floors. So for example, we can start at the ground floor and move all the way to the roof. To do so, you just place it on a pipe or anywhere in the diagram. Cancel, and now we can move up to the roof, and here's the connection point. So if I draw a horizontal pipe from here, for example, horizontal pipe. Now when I refresh my drawing, you can see that I have a riser pipe attached on the ground floor all the way up to the roof. And the other is known as a vertical pipe. So I go back down, and if I connect my horizontal pipes, in the diagram at least, we can see that obviously they're at different heights, so there is no connection. And this is where you use the riser pipe to connect pipes that are on the same level, same floor, but at different heights. So if I attach that there at the connection, and I refresh, they're connected with a riser. And the last element that I would like to introduce is the hangers. So the prompt here You can choose the series of hanger you would like. You can choose the size of hanger you would like. You have some settings related to the pipe that it will attach to, but as you can see, they have an open lock, so you can ignore them, and the software will automatically update that information. And you also have a number of checks which aren't relevant yet, as it's not attached to a pipe, but they will update once you've attached them and run the analysis. So I will attach 3 hangers like this, refresh, and there's the hanger in the 3D model viewer. Okay, so this is just a simple demonstration for the placement of elements, but to show you a proper sprinkler installation design, I'm going to open up a finished model just to save some time. I'll load the examples, and we have the finished office. And there we go. So you can see here's our supply connection. We have a pipe feeding each of the rooms. We have hangers, and we have a riser pipe which connects each of the floors. Okay, and so once you've finished your installation, then you can use the analysis tools up here. So when we calculate, it says the calculation has been carried out correctly. And once you've carried out your analysis, the software will locate the most hydraulically remote sprinkler in your installation, and it will put a white circle around it. And this is important because in order to verify your installation, you need to include what is known, as the area of operation, which is this area here. And this needs to include the most remote sprinkler in your installation, just to ensure that it can fulfill the most demanding operation in the building. So we've included that. And so next we have a number of options for displaying the results of the analysis, one of which is a visual tool, which is the graphical analysis of the results. If we activate this, we can show graphically the flow, the velocity, the pressure loss, length, or the height. If I accept, it will show graphically on the pipes the results of the analysis, which you can view in the 3D view as well. Just like so. And the other options for viewing results, we have the reports tool here from the file button, where you can generate 2 different reports. The project report will show all the results from the hydraulic analysis, including the flow test summary sheet, the results of each individual node, and the results of each of the pipe segments. And next to that, we also have the materials sheet, which will show each individual component that you've used as well as the quantity. And below reports, we have the drawings tool, which will generate engineering drawings of each of the floors that you select. Accept. And then click detail of all the drawings to see each of the floor plans. And it's worth noting that it will automatically generate a table here with a legend, a symbols table. However, you can add in any sort of table you'd like using the tools built into the software. As you can see, it has pipe diameters, all the sprinkler locations, pipe locations, hangers, hanger diameters, any of the information that you need. And this can be exported or printed. So I'll close this. And so now we've finished with the sprinkler installation. So back to your question about the introduction of different normative standards. In the new version, you'll be able to set up Sorry, in the new version, you'll be able to set up whichever code you want to. You'll be able to custom make the code in the software. And we will release this new version next week. We'll write you mail. We'll let you know by email when it's available. So could you just write your email address in the chat, and we will send that information to you. Okay, so now that we've finished the sprinkler installation, I'm going to add this to my project. Demonstration. And finish. Okay, and now we can export the results. Okay, thank you for your email. So the export's finished. We can check the BIM synchronizer. It might just take a minute to update. Okay, it says it's finished. Let's just check on the project, administration. And so there we go. We can see that the sprinkler information is loaded. And if I open up the 3D viewer in the BIM Service Center, there's our sprinkler installation. Okay, so everything's up to date. Now we can open our model, including the sprinkler installation with CYPEFIRE FDS. Select project. And just import the sprinkler installation. So the main purpose for CYPEFIRE FDS is the simulation of fire evolution in complex building models using the Fluid Dynamic Computational Standard FDS Fire Dynamic Simulator. Okay, so there are two tabs separating the two phases of the program. This is the first tab, the BIM model, and this is where you set up the 3D model for analysis. And so the process starts with the libraries of the construction elements, the openings, and sprinklers. So the first thing I'm going to do is check for errors. And you can see here at the bottom that all of the construction elements that make up the model have not been defined correctly. And so each of these construction elements is an individual element in the model, but they're all associated to a certain category, such as screed, floor slab, external floor slab. And these categories need to be defined in order to be exported to the FDS model. For example, if I open up the screed category, I need to define each of the layers that make up this construction element. I'm just going to do a quick example. Like so, but obviously this will be made up of multiple layers, but just to demonstrate, if I've defined the screed now, we can see that WL1 is defined correctly, and now if I export, only the elements that have been defined correctly will show up in my FDS model, and so you can see the only thing that I have is the screed and a number of sprinklers. Okay, so instead of going through and defining each of these individually, I will open up a completed project, save some time. Okay, so now when I check for errors, the model is correct. These construction elements have all been defined. It's important that each of them have a defined thickness. That's the only property that is important in this stage. And so the next thing you need to worry about with the BIM model is just the mesh. If you double click on the mesh here, you can define the dimensions for the mesh that you like. You can change the coordinates as well as the number of divisions for each axis. And so if you increase the number of divisions, obviously you will have a higher fidelity mesh. However, it will take a lot longer for you to calculate your fire simulation. So you need to balance this computational time with your accuracy. And one of the methods for doing this is to use multiple meshes. You can introduce multiple meshes where one mesh will have high fidelity in a certain area that you're really interested in, whereas another mesh can be of a lower fidelity just to maximize the computational efficiency. We're going to leave it like this, as it is. Okay. So I'll just get to that question in a minute, but let's move on. So we've checked the errors. We can export to the FDS model. So now it's going to use this information that we've completed, and it's going to generate an FDS model that can be read by the FDS engine. And there we go. This is the FDS model. And from this window, we set up the configuration for the fire simulation, basically. We have a number of settings at the top for adjusting the simulation time, the environment, things like you can adjust the gravity, you can adjust the wind, you can adjust the radiation. The first thing I'm going to do, though, and the first thing you should do is, again, check for errors just to make sure the model is correct before you start adjusting your simulation. Okay, so now in the project tree, you have all the necessary variables for configuring your fire simulation. First in the library, which is completely configurable and allows the manual introduction of any element. You have the pre-configured species of chemicals. Below that, you have materials, including all the properties necessary for fire simulation, such as conductivity, density, and specific heat. This is all information that you will have to input. Next, you have surfaces. Below that, you have particles, which will include water if you have imported your model from CYPEFIRE sprinklers, but it can also include solid particles and massless particles. Reactions is where you will introduce the combustion reaction. Here we just have a wood combustion reaction, which includes the composition of the fuel and the products. Below that, we have a number of different products that can be introduced, such as a heat detector models, smoke detector models, thermocouple models, sprinkler models, which is the only one that we have included, and the nozzle models. Okay, so after that, we have the model section where you will have the ability to, again, alter the mesh, and you can configure zones, initial regions, obstructions, holes, vents, devices, controls, and slices. For this demo, we have an obstruction we have introduced, which is the source of the fire, and we also have a number of slices, which are useful. We also have a number of slices which are useful for displaying the results of the fire dynamic simulation graphically. Okay, so if I go to my obstruction, which has been named fire load, I can open that up. We have the dimensions for the obstruction, we have the properties, and in the surfaces, you'll see that the Z-Plane Max, I have created my own surface called burner. And so if I go into surfaces, where I have created burner, there it is. I have adjusted the color so it's more obvious, but more importantly, you can adjust the general properties such as the materials, which I've determined as wood, the thermal properties, and the pyrolysis, and the emission. Okay. So now that we have, we've introduced the obstruction, we have everything ready for our fire simulation. The building is configured, and as well as the ignition source. The next step would be to begin the analysis, which you would do using this button here. However, again, this is going to take a long time for a building of this size, so I have prepared an analysis earlier. So I can cancel this simulation, and we can open an already finished version of the same building using the smoke viewer, which is coupled with CYPEFIRE FDS. And here's our building. Okay, so we have a number of tools which you can activate using the right click. Firstly, I'm just going to define the building as outline only, so we can see into the center of the building. There is our obstruction where the fire will start. So firstly, I'm just going to activate both the smoke and the fire. And as you can see, the room is filling with smoke. You can see where the gases move. Okay. You can also adjust the frame rate, and so the time of the simulation. But the next thing that I want to add in is the particle file, just to demonstrate the effect of the sprinklers, or demonstrate the activation of the sprinklers. Okay, so you can see the fire starting, and then once a specific heat is reached, the first sprinkler will activate. This is an unlimited fire source, so the sprinkler can't win, but it does demonstrate the activation of the sprinklers. As the simulation continues, some of the other sprinklers will activate. There's another sprinkler, I think. There we go, there's another sprinkler, another sprinkler. Okay. So I'm just going to turn off the smoke so it's a little bit easier to see. But the next thing that I would like to demonstrate is the slice files which we've inputted. So we have a number of slice files for different different results, such as the temperature. So the first one that I will show is a Z slice for temperature, which is a very useful visual tool. You can see the first sprinkler is activated. Room is still heating up. And then once sufficient heat has reached the other sprinklers, they begin to activate, and you can see the reduction in temperature. And another, oh, sorry. And I can activate the Y slice as well. So you can obviously have those running simultaneously, or as many slices as you like. Okay, and so some of the other slices that we have. Vector slices as well. You can show the propagation of the smoke as a vector. I might just remove the particles a bit clearer. So as you can see, it's a very useful graphical tool for the analysis of the propagation of smoke. I can unload those. Okay, so I think that is basically what I'd like to demonstrate. If you have anything else that you would like me to show, please write some more questions, and I'm happy to show you. Otherwise, I'll answer them after the presentation. I can send you by email. Yes, please let me know. And so to Carlos's question, right now we don't have predefined element libraries. However, if you look up the SPFE handbook on Google, which I can do right here. It's free to access. And so okay, let me go. For example, we have here the properties of non-metals, and so this is all the information that you need to input into CYPEFIRE. For example, here, this is the information that you need to fill in for each material. And we are working on introducing libraries in the next version to make it a bit easier. But for now, this is the only way to introduce it. Yeah, I hope that answers your question.